Welcome to the Workflow Show. This is Nick Gold, and I am here with regular co-host Jason Whetstone, as well as our
everyone.
Producer Ben Kilberg.
Howdy.
And today we have a special guest on the Workflow Show. This is
Sure is special.
Senior Systems Engineer of Chesapeake Systems, Brian Suma.
Hello.
Brian is really more or less the guy behind the curtain, I'd say, at Chesapeake. More than anyone else, because there's a lot of key people at Chesapeake, but Brian is the one we try to keep out of the public eye. I mean, he's just so busy with orchestrating things from behind the scenes and making sure that our technical staff, our support staff, our project staff are doing it right.
And what I can say from the non-sales side of the organization, he is the person that we all go to when we have questions. So he is like our number one resource.
I think the phrase I have used is kind of spiritual leader.
He's the great and powerful Oz.
Yeah. So Brian, as our senior systems engineer, I have had the pleasure of working with for the last 12 and a half years. I've been at Chesapeake. Of course, Brian was at Chesapeake before me, Nick, and not many people in the Chesapeake organization can say that. Brian was of the two original members of the Chesapeake Systems Pro Video team, which included himself and Christian on the biz dev side, Christian Malone. Shout outs to Christian if you're listening, and Brian. And Brian was the one who was saddled with having to make all of this technology work for video editors and producers and broadcasters and all of that. And so Brian has many projects under his belt, and Brian was really the main person to get us into more sophisticated storage systems at Chesapeake Systems, which of course is a big part of what we do today. SANs, file servers, most of our activities in these areas are the brainchildren of, dreams come up with by Brian as far as areas that we could wade into. And so Brian is really our main storage guy, among other things. And so for today's episode, I thought we would talk, Jason, and the rest of you guys, about file systems and beyond.
Brilliant.
Ben, that's where you should, in post, put the echo on beyond. All right. Maybe that's just enough of that right there. So, file systems. What is a file system?
What is a file system?
We throw that phrase around so much at Chesapeake Systems. We talk file systems and volumes and drives and all these fun things. So, Jason, let me ask you, before we get to the expert in the room. Well, you're also an expert in the room, so I just kind of was looking in your direction, so I thought I'd ask you. Jason's like, I'm an expert.
Expert on.
Jason, what do you think of when you think of a file system?
Well, it is a layer of abstraction, I guess, or a layer between the operating system and the storage media. So the storage media would be your spinning disk or your SSD, and the operating system would be your Mac OS or your CentOS or whatever you got. What is communicating between the operating system and the disk?
So, okay. And Brian, we're going to kind of stage this for you to just explode all over.
Okay.
So this is a little leading here, of course, but let us continue to lead this a little bit. So, Jason...
by the way, that was a definition that I kind of came up with in my own head when I started hearing Brian talk about file systems many years ago.
Yep.
Because I had never heard of the term file system before.
But you were
so I was like, I wonder what that would be. Well, it's probably...
But you were using them, right?
Absolutely.
In fact, I think I can make this claim, that if you have been using a computer, really at pretty much any point, if you've owned a computer, including a mobile device of the last 7 to 10 years or whatever it's been, a laptop, a desktop, your smartphone, you're using file systems all day long. You might have even created one, right?
Sure.
So when we'll have some of our customers, including the non-IT support staffs, just any Joe or Jane computer user, when would they have had reason to more directly interact with file systems, Mr. Whetstone?
Well, you mentioned creating one. When you go to Target or Walmart or Best Buy and you pick up a 1 terabyte, external drive,
Like
and
a
it's
USB drive.
a USB drive, and it's $59 or something like that. And you're
So
like,
you're
wow,
saying
that's a great deal.
It could be a hard drive. It could be an SSD.
Yeah, it could be a hard drive, it could be an SSD, and you bring that home and you plug it into your Mac OS X Sierra machine.
Sometimes something happens.
What happens? Well,
dialogue comes up usually.
something comes up and says, "Hey, this disk is not authorized for use on this, or not."
It says you have inserted a, what's the exact phrase? Brian, you probably remember it. You have inserted a drive.
It basically
not
says this
readable
drive
by
is
this
not readable by
operating
this machine. Do you want to initialize
The
it?
drive is not readable. Okay, so in the world of IT, which, yes, we do inhabit, in addition to the world of media, we think of our IT solutions as sort of bifurcated, right? They have two halves to them. There is a physical part of them, which is the hardware.
Spinning drive or the SSD.
I mean, it's the little pieces of metal that they're held within. It's the magnetic recording media with the magnetically adjustable, bits essentially that little platter reads, or it's the little flash memory-based thing. But it's obviously the thing you can throw at the wall. Mm-hmm. But there's something you can't throw at the wall.
Which would be the software portion.
Software.
And let's just all take a minute to remember that most of what we all do every day is just rearrange magnetic powers on a piece of metal.
Yeah, it's true. I mean, the majority of the world, it's funny. We sell a lot of storage. We've sold petabytes and petabytes and petabytes and petabytes of storage in the 13 years or the 15, 16 years which Brian and I have been with Chesapeake. And most of our clients, and frankly, I think less our own staff and our own side, but I think most of our clients, they think of this big storage system, and they think of those RAIDs in the rack. They think of that server that they're all connecting to at the office.
Right.
They think of flashing lights and something that cost a lot of money, and if they go into their server room or they go to that little equipment rack that we set it up in, they can knock their hand on it if they want. There's cords plugged into it.
The files are in the computer.
But we know that there's a layer to all of this that is software. It's bits. It's how the information itself is organized, not the physical medium that the data is stored on. And that layer that's non-physical entirely, other than the energy that defines which position the bits are in, and then how the bits process other bits, it's that's invisible to most people, and yet that's as big a part of the storage system that someone is buying from us.
Absolutely.
As the hardware, right?
What would the files be without the file system?
Well, and that's what we're going to get into today. And today, a file system, you could make a career of it, as Brian and some others have, and people who write file systems for a living, and companies that we work with that sell file systems and just the file system. So today's episode, we want to try to just quickly offer a primer to our clientele or our listeners as to what a file system is, what are some basic ones, what do they do, why is looking into the file system side of a storage system that you're considering an investment in as worthy as looking at the hardware or any other spec to the storage system. Yeah, how many people are connecting? What's the bit rate? What kind of switching are we using? Is it a fiber channel or an Ethernet network? How's the traffic all work? But okay, those are all important factors. We talk about those all the time with our clients. We don't tend to get as deep into the file system conversation, and it's something I think our clients should be more aware of as another very key aspect of what they're making the storage system investment in.
Absolutely.
And this is where I'm going to just chime in really
Please.
quickly. So the reason why it's important that people understand about the file system layer, it also will help kind of drive home the point that we make on a daily, if not hourly basis to many people, is that RAID is not a substitution for backup. At no point in time should RAID ever be, considered, well, I don't need to back up my data because
it's RAID protected.
I'm RAID protected, because the part of the part of that they're usually missing is they're forgetting about the software wrapper that goes around that. Like we were talking about the physical medium. So Jason had already said that there's the SSDs, there's single disks, but then there's also the RAID, which, presents itself as a single disk to the operating system. But
it's made up of many disks.
Many disks. So one of the issues is that in order for those to be able to be used with your operating system, you have to put a wrapper around it so that the bits and the bytes that you want to save long term, they have a structured means in which they get written to the disk, so that then the operating system knows how to retrieve them, number one, and also how to append to them or modify them or secure them, with things like permissions and securities and things like that. But moreover, I think a lot of people think, all right, well, I don't need to worry about a backup because I have RAID protection. And while RAID protection, yes,
It's a layer of safety, maybe.
It's a layer of safety. Really, at the end of the day, RAID is to really minimize downtime. The likelihood that you're gonna have a hard drive failure is pretty significant as they grow. The more hard drives you put into an array, the more likelihood statistically that you'll have a failure. But losing a drive or two, depending on your RAID level, that is not about data protection. That is about uptime and making sure that you minimize the impact to your business.
Yeah.
Right? Because on top of that RAID set or that physical medium is the file system layer, and you can always have file system corruption. Or moreover, what you can have is you have a user who deletes something that they didn't mean to delete.
Yep.
It's still only one copy.
And it's still only one copy.
Okay, so let's just pause for a moment. We're gonna get into this, but I like the points you guys are making, which is that when we look at storage, when we quote a storage system, when we support or deploy a storage system, we inherently look at it as this multi-layered beast, right?
Absolutely.
We see servers, we see physical drives in servers, we see RAID controllers and interfaces to networking connections, we see the network itself, we see servers that are maybe managing that storage network. There's all of this stuff that we see when we sell these things, and yes, the file system layer is just one, and it's
one layer of that,
and it's one that can cause
multi-layered cake.
Problems, much like having a drive fail can cause problems. Having a RAID controller that has cache memory that got corrupted can cause problems. Accidentally deleting a file or a malicious user formatting your entire SAN can cause problems. And so I really want people to understand that this file system is it offers its own features, but it also offers its own sort of risks, and there are file systems that are more or less appropriate for different tasks. So let's
absolutely
start with that basic scenario, the one that our users are familiar with. You pop in the drive. A little dialog box comes up. It says, well, this is kind of a dumb piece of hardware, right? This is a dumb piece of hardware that I don't know how to understand because it's lacking something. You have to press OK to format it. That's the big thing that most people are familiar with. I have to format a hard drive or an SSD that I plug in or a USB stick. So when I look at this act of formatting a physical recording medium, like a USB stick or a hard drive or an SSD or an entire RAID or whatever it is, I think of, and Brian, I want you to tell me, am I right? Am I wrong? Is there more nuance to it? But I think of these file systems as kind of being two things first and foremost. Number one, if I am in front of a computer or I'm, not formatting a local hard drive, maybe I'm an admin like you and you're setting up a shared storage system for someone. But when it's time to create the file system, number one, there is a whole layer of software that might be baked in at the operating system level for a various computer. It might not be baked into the OS per se. It may be kind of an application layer on an overall storage platform like StoreNext. You have your StoreNext management servers. They're running sort of the StoreNext software. And so the first thing with these file systems is they are a collection of software, of actually essentially applications that are running either on the storage platform and its system or even just your desktop OS.
Yep.
And it's the software that, first of all, is capable of organizing data in a specific way. A specific file system is supported. It has that specific software. When I pop in that drive to a Mac and I get that dialog, it gives me a list of a few different formats or a few different file system formats that I can turn it into. HFS, HFS Plus, HFS plus journaled, case sensitivity. These are, there's all these flavors.
Fat,
Well,
exFAT.
there's something also to keep in mind too. For the average Mac user, a lot of what actually is happening when you format the drive is obscured from the end user. So when you click on a drive and you basically say erase, the two things that it's doing simultaneously is, one, it's putting a partition map on the drive itself, and then it's then putting the file system down on top. On a more sophisticated operating system, like say Linux, even though there are a lot of desktop Linux solutions out there that have a very similar disk formatter, when you do it at the command line level, you can really sort of see that the very first thing you need to do to prepare the disk to even put a file system on top of it is to put some sort of
Partition map.
So
map.
it's almost like the partition map. I just want to relate this, like, metaphorically, right? It's almost like before you build a building, before you even get to the foundation, you need to grade the land. It's almost like the partition map is a little bit like grading it. It's getting it ready for the foundation.
I don't know. I wouldn't go that so far. What I would probably, if I was trying to make a similar sort of metaphor, is I would say it's if it's putting up new construction and you've got drywall, and before you lay down the paint, you need to put on primer. All right, because you need something that the paint can adhere to pretty well.
I like that. You're painting a wall.
So you need to put down the primer. So the primer is real basic. It's usually, it's gray, it's white, it's whatever, it's nothing. There's no pigment to it. But its main job's function is to make sure that the paint that goes on top of it adheres in the best, most even manner possible, right? So if you think about that, when you wrap so what you can do is you can wrap a hard drive, and that partition table that you're putting on top of it, it does a lot of things. Like one, it says, am I going to have one file system or many file systems? Okay. So you can have a single physical disk, and then you can carve that up into, multiple segments, because maybe you have a reason to segment your data. Besides telling it that, it also says, it tells the file system, how big the individual drive can be. So if you get a MS-DOS, file system, they usually don't handle drives larger than 2 terabytes. With something like a GPT table, a GUID partition map, something like that, they can handle drives, a single drive. And again, we're not necessarily talking about a single drive. We're talking about a single
Volume.
a single piece of medium. So you might have 4 1 terabyte drives that presents as a 4 terabyte volume because they're a RAID 0. But at the same time, like, the operating system, because that's happening at a much deeper level, doesn't know that. It just sees this big giant thing. So the partition table says, all right, well, you've got 4 terabytes. If you use the wrong partition map, you're not going to get access to all that. Okay, so the different labels that just basically that, and that has, and then in Linux you get into there's the physical volumes that are their volume groups, and logical volumes that basically allow for you to sort of shift and resize things. OS 10 in the most recent years, they have core storage, I think is what it's called now, which is basically just a ripoff of Linux LVM, in my opinion.
And again, everything you're talking about now is just happening at the software layer. It has nothing to do with the physical hardware.
No, see that's the trick. I wouldn't even call it at the software layer at this point, because when we talk about a file system, we're talking about kernel extensions, we're talking about modules. So it's almost like at a driver layer. Mm-hmm. So you have a driver that says, I can connect to this piece of hardware either using a SCSI protocol or some variant of that. But then, like, the next step up, you have a module that basically then says, okay, now how do you interact with this?
So if that module is sort of the layer of the OS stack or the storage platform software stack that kind of mediates, the file system, part of the second thing that I think of when I think of what are these file systems is I think of a usually hidden, subtle, not a file that you can find as a user sitting on your drive, but essentially what is an invisible layer of files, an invisible layer of data that is stored on these drives, right? Like when you format your drive, one of the things that people notice is, oh, it's not quite as big as the box said it was going to be. And there's a few reasons that can occur. It can have to do with whether you're looking at things in base 2 versus base 10, and some manufacturers look at one versus the other. But let's say it's not the base 2, base 10 conversion issue of whether you're actually talking about megabytes or mebibytes, which is a whole other workflow show waiting to happen.
Yeah.
But let's say it is that formatting act. I formatted it, it's now a little less. Well, it's because when you have formatted that drive with a file system, it created a data layer on the drive that you can't really see directly as a user just going through the file system hierarchy.
Right.
But it's on there, right?
Yeah,
So,
it tells you things like, because that's one thing is without that partition label, the operating systems theoretically would not know the difference. Like, so when we see a drive that's called, Macintosh hard drive, or you see a drive that's called Capture Scratch or whatever, DeLorean, because some people are clever and name that as their time machine backup. The problem is you can have another drive that's a human readable label that's meant for us. So the problem is without that machine label, which is really not, I'm sort of just making up a term here, but without labeling it in a way that the machine understands that this is a unique thing, you could have data collisions because you could have two devices that are named the same thing, but the operating system wouldn't really know the difference, because you could have two identical 3 terabyte drives. You could format both of those drives as HFS plus, and without that subtle hidden metadata layer that basically says, well, yes, I know you think this is called DeLorean, and I know that you think this is called DeLorean, but really the operating system sees this as a universally unique identifier, a UID, right? Where it's got some sort of 32-bit hash on it. And you can see this a lot of times in the command line. You can say, okay, how do I know the difference? Because drives a lot of times they randomly show up, and so they get different device labels. So in OS 10, a lot of times you'll see something that shows up as like DM1, DM2, or disk. Or OS 10 it's actually disk 1, disk 2, disk 3. Right. So, but that has nothing to do with the actual disk. That just has to do with the order that it happened to pop up. So, at any given point, if you reboot your machine, you might have a disk that says it's disk 1, and then and another disk that's disk 2, and then you reboot, and it just happens to be that because the machine saw the other in a different order, then the other one shows up.
So let me pause you for a second. You said you used a word that we use a lot at Chesapeake Systems, but you used it in a way that's a little different than how we use it a lot of the time when we use it. Our favorite word, metadata, which we say left and right just to sound like we, have tweed jackets with, leather elbow patches on, and we smoke, pipes. And
fair enough.
Which we may or may not be doing while we're recording this episode.
My elbow patches are suede.
So when we talk about metadata, a lot of the time with our customers, we're talking about databases, we're talking about MAMs, we're talking about, here's CatDV or Reach Engine or Cantamo or this or that or the other. And we say, you can say, well, who shot this? And was it B-roll? And was it a good shot? And what time of day was it recorded? And what's the time code? Those are all forms of metadata. But you just used the word metadata specifically referring to this kind of quasi-invisible data layer that gets put onto these volumes. Right? I format it, it's now a volume. That's true whether it's a giant petabyte thing or whether it's an individual drive on a USB cable, plugged into my computer. So when you use metadata here to talk about a file system, like what type of metadata are we talking about?
I mean, it's machine level. So what it does is by having that partition label, it's going to tell the machine, number one, like when you plug it in, because here's the thing, in Jason's scenario earlier, he said, I went to the store and I bought a 1 terabyte drive and I plugged it in and it prompted me to initialize it. That's not always true anymore, because a lot of times drives come pre-formatted. But in the case of Mac versus Windows, 90% of the drives, and that's just a made up percentage number, but are formatted probably for Windows, so NTFS, right? So Macs only have a read-only driver for NTFS unless you're using a third-party software like Paragon, right? Not promoting them in any way because there's no need to. But the reality is that when you put that disk in, it can read the partition label, and the partition label then will inform the operating system that, yeah, there's a label on here, but guess what? You don't have the file system module or driver or kernel extension to actually read the file systems on here. And then that's what prompts the disk arbitration tool in OS 10 to pop up and say, hey, you need to format me. It's not necessarily that it's not formatted. It's just not formatted in any way that particular, but that's done at that partition label. So a lot of times it can read that label, but because it doesn't have the software to understand the next level up, which is the file system. But yeah, I mean, basically, metadata in the way that we normally talk about it, if we break it down to the simplest form, is always metadata is data about the data. So that metadata label that's on that disk, it's describing to the operating system to expect.
It's literally down to the level of hard drives, the kind of granularity with which they record data are referred to as blocks typically. And so, I mean, it's literally like this portion of this file is at these string of blocks and the file continues at these ones because I couldn't write contiguously. By the way, this is also the name of the file. This is, by the way, the whole directory structure and the name of every directory and where things are organized. This is the file creation date, modified date, last open date. In fact, different file systems have different types of metadata that they generate now.
And other operating systems, the partition table is also where you store things like whether or not that device is bootable. So for instance, if you have a Linux machine and if you have ever run through the setup a system, it'll actually tell you, so where do you want to locate the boot sector, and typically it's in the partition label itself. So, because that gets read by the machine code, because the machine code is what's loaded before the operating system. So
these file systems are a layer of metadata that gets stored on
the partition table is a layer of metadata. I keep bumping the microphone.
Okay, so the partition table is this very subtle layer of metadata.
And we typically try to make the distinction between file system metadata by calling it file system metadata just to not confuse it between, say metadata and CatDV or Reach Engine.
So let's just say this. Let's just say that really what that partition label does is that's to identify to the machine at the machine code level what to expect on the disk before the operating system level loads.
So really, the partition map is a layer of metadata, and then the file system is really kind of a layer of metadata on top of that.
Well, the file system contains metadata.
Yes,
I don't think it necessarily is metadata.
That is one of
the file system
things.
is the structure in which the data is stored.
Now we have tools to interrogate file systems, but these are not always tools that end users are familiar with. Correct? Like, there are tools that I'm guessing are like command line apps.
Well,
right?
that's just it. So that's where it is. So not all file systems preserve metadata. That's why you can't say that a file system is metadata, because so some file systems are extended. And I'm not trying to use that word to confuse it with Mac OS extended, but some file systems are extended in that they can actually contain things like extended attributes.
Sure.
They actually preserve certain bits, like so that they preserve like POSIX compliance bits, like user owner group.
I guess
not user owner group, user group other. Or owner.
So I guess when I say that the file system has some other metadata, I even mean like the directory structure and the name of the files, right? Those are stored at the file system level.
Yeah, but calling that metadata isn't really quite the same, because when we think about harvesting metadata, yes, the path in which the file is stored might be considered metadata to us, but when we talk about like a deep dive into it, we're talking about things like the A time of the file, the C time, the B time, basically when the file was born. You want to if it's
where on the physical disk is the file located?
Where the like what blocks?
Okay,
yeah.
So what's
not what folder it's in, but what block
what's
on the disk.
So you can even use some commands to know which blocks a file is on.
Absolutely.
To know whether or not it's a you can even know if it's a special file versus a regular file. versus a directory entry.
Okay,
versus,
so there's all of these additional pieces of info about the data that we're storing on whatever
but
type
it's
of storage system.
dependent on choosing the right file system.
This is a good segue then. We've covered a number of areas relating to file systems. They have to do with this layer that gets put on top of the partition map. It kind of is some very specific metadata about about where the files are, which blocks they're on, all of these characteristics of who gave rise to the file, when it arose, all of these things. I mean, something that a lot of people don't know is like, you know how when you had delete a file, you actually have to like really write over the data for it to truly be deleted. Because otherwise it's just a little flag that gets set at the file system layer, right? That says you can write over these sectors of the disk now.
Absolutely.
So again, like that's all happening at the file system layer. So, we talked about a few of the local file systems. We said, okay, if you're a Mac user, chances are every freaking hard drive you've formatted in the last almost decade has been
Mac OS Extended.
Mac OS Extended, which is otherwise known as HFS Plus, and then with journaling is this new capability that they added in maybe about 8 years ago, if memory serves.
It was in server for a while, and then I think they kicked it into everybody with like 10.2.
So it's an interesting thing, actually, that I don't want to go too far into, but when Apple modified HFS to add journaling, it was a feature that was introduced into the file system. What journaling did was create a little index on the drive. And if I remember correctly, it was largely to help prevent data loss and data corruption in the case of volumes or file systems being unmounted or essentially ejected from your client, your host, without being properly shut down. And so, because it's very easy to accidentally just pull out a desktop
USB
drive,
cable.
USB cable, trip across something. With HFS Extended, HFS Plus, which is a very old file system at this point, like decades at this point, or at least it's
over 20 years.
The original one is over 20 years. That was leading to constantly people needing or either losing data on their Mac drives, having to constantly run things like Disk Warrior or Apple's own disk utility tools to fix corrupted volumes, because one of the leading causes of file system data corruption of both the file system data and the actual data was these pulling drives without properly ejecting them.
Power outage if it's your internal
All of
drive.
that stuff.
Yeah.
So journaling was a feature that Apple added to the file system that made it so each drive, which had its own file system or file systems, was a little more resilient and kind of was on, I guess you could say, on a more ongoing basis, doing a little housekeeping behind itself so that if something was disconnected suddenly, there was less of a chance that disconnection would lead to corrupted file system metadata and or data on that drive.
Well, I think the hope or the intention is that if you're in the middle of a write, when you started back up, instead of the whole disk being corrupt, just the file that was being written to it.
Yes, that's right. And so one thing I'll just note of interest, for many, many, many years, a lot of us in the Mac community have kind of been waiting with bated breath to hear, Apple, are you ever going to do something beyond HFS Plus with journaling? And what's interesting is they have finally announced, after many years, that there is indeed an active project to transition us into the next generation Mac file system.
But it is also nothing to hold your breath about.
So why do you say that?
So it is not a modern file system in the sense that it's not like a ZFS, it's not a BTRFS or ButterFS.
We'll get into some of these a little more in a moment.
It essentially what it is it is their effort to have a single file system that crosses all their different operating systems. That is the main.
So something that's as useful to Apple on an iPhone as it is on a laptop, a MacBook, or an iMac or a Mac Pro.
Right. That is the main thing. But it doesn't have any advanced functionality like a lot of people were hoping it would, like copy on write.
Well, we'll talk about advanced files. Okay, but
coding.
What I did think is interesting is that it at least represents some additional features beyond the file system. I think.
Yes, but it's very self-serving. That's the big thing.
Really, Apple making a move?
I know.
Self-serving.
It's just like, wow. What?
Not for the greater computing community.
I know.
Whatever do you mean? Whatever do you mean?
But yeah, yeah, it is. It is. Now, I'm not saying that they won't be able to, because it's more modern code. They're not going to be able to write additional features into it, because if you look at what they did with HFS, it's pretty amazing.
They added layer upon layer of functions.
They really drove that into the ground.
I know, right?
Quite honestly, it's kind of amazing. I think I forget the guy's name off the top of my head, but even the guy 20 years after the fact, when he looked at all the little patches that they did on top of his original kernel code for HFS, like he was just like, I'm surprised that they were able to get it to go as far out.
And so maybe, and let's all cross our fingers here, maybe this at least represents a good new foundation on which Apple can build the next couple of decades of file system development. And, something that Apple has always done, they've sniped some very well-known amongst this community of people, which is maybe not the mass population, but Apple has sniped some well-known file system developers in the past. I don't know if he still works there, but I remember when B, and very few people remember the B operating system at this point, but it was at one time looked like it could emerge to be a very mainstream system. I think Apple grabbed the guy who developed B's interesting file system at the time, but again, there was very little evidence that it was really coming together into something we were using on a day-by-day basis. So maybe this is a sign that Apple is really reinvigorating the file system team, but maybe taking a piecemeal approach. Okay, so we've been talking about file systems, what they are, and that they have features associated with them. One of the features that's probably worth us taking a moment to chat about, guys, is that some file systems are inherently designed to have just a single user interacting with them at a given moment.
Right.
And some file systems are inherently designed to have multiple users. And remember, when we talk about users here, guys, and we'll go through some use cases in a moment, but it could be a computer that is a user to a system, like a server with a piece of software that automates certain tasks, or it could be an actual human sitting in front of their editing workstation.
So just to reiterate that, a user could be a machine or it could be a person.
But some of these file systems are designed for one user to be modifying them, and some are for many, right?
Well, I want to just clarify. So most file systems can handle, in fact, I don't know of a single file system besides maybe ISO, like what you would find on a CD-ROM or something like that. But most file systems are inherently multi-user read.
Multi-user read.
Right, because having, it's not saying that you can hook up 5 people to a single drive, and unless you do some really cool finagling with the kernel, it's going to try to mount that drive as read-write for everybody. But most file systems can handle multiple reads. It's multiple writes, which is where it all falls apart.
So what's the difference as far as a file system is concerned? Not that they are, because they're non-sentient, unless you believe in panpsychism like I do, but that's a totally different subject.
Panpsychic file systems?
No, panpsychism. It's the belief that consciousness is sort of baked into the physical reality of the universe. But again, subject for another day. So
the great file system in the sky.
For the time being, wink, wink, nudge, nudge, let's assume that file systems don't think about things. But if they did, I guess, why does a file system care? Or why is it a file system okay with multiple people reading data off of it at once, but not okay with multiple people writing data to it? Or, as we sometimes would say, doing anything that modifies the data, whether it's deleting data, changing data, adding data to it. Those are all writes versus reads. So why does a file system care whether people are reading or writing? Why would that affect it differently?
What happens when 2 cars try to be in the same space at once? They crash. It's a giant mess,
what does that?
isn't it?
So what does that mean? What's
Cannot
going on?
occupy same space at the same time.
Well, I mean, the reality is that the reason why I can handle multiple reads is because when you are on a multi-user operating system like OS X or Unix, and even if you only have one user account, you have to realize that there are so many daemons that are operating as a process, reading different things in the background.
Demons, you say?
Demons, I say.
Aren't those the cute animals in the Golden Compass series?
No, I say
follow
daemons,
everyone
and I'm sure
around?
that people will find fault with that because they're if he's supposedly the.
They are DAEMONs.
I say daemons because
I say daemons too.
that
So
is
how
my
can we
preference.
how can we take a look at all these daemons and what they're doing?
Wait, what is it? Why are we talking about demons, guys? What's
So
a
a
demon?
daemon
Conjures them from your file system.
It is a process that runs in the background on your computer. It's not
As a
something
user.
As
Or
a
lies
user,
in
exactly. It's not something that you intentionally started. The mere act of turning on your machine and starting up Mac OS 10 will spawn a ton of daemons.
Crazy, guys. So I'm turning on my computer, and I log in, and maybe I care a little bit about security, so I always set it up so the login screen comes up, and I type Nick Gold, and then I type Jabberwocky123, which isn't my password, by the way. I said don't even try it. But I type whatever my password is. I come in and I think, okay, I am a user logged into this computer. You're telling me there's all these like demons,
Processes and
demons running
subprocesses
around
and
that are
little
also logged in as. Why the heck
applications
did they choose to call them demons?
Spotlight,
just call them angels.
Metadata D and Spotlight D.
Can we
and-
call them ghosts?
So what you can do, and I encourage anybody who's interested to try it, open up the activity monitor in your utilities folder
This is on a Mac.
and switch the view in the, I believe it's the window menu, switch the view to view all processes.
And this
you
is
will
the
see,
process owner column, correct?
yes.
Or
and
just
you will
open up a
see-
terminal screen and type top.
Yeah, there's another way to do it.
But
But you will see a ton of things running. And these are all things that are essential to the daily operation of your Mac.
So what's like a super common one that's always running in the background?
launch D.
So
D.
the launch daemon.
Yeah.
And this is, if I remember correctly, it handles what processes start up when you turn on your computer.
It runs
It's-
about 11:45 and tells me I'm hungry.
It runs. It's clever. I like that. It is. It's what replaced like init scripts back in 10.3. So I think 10.3 was when they first implemented launch daemons. But it's what spawns all the services. So if you ever look, it's whether one. It starts spawning services that might tell other services. to
Okay, so
start
let me throw a
dependencies.
curveball at you gentlemen, if you're so smart with your demons and users. And if file systems are typically only one user read at a time, one user writes data at a time. One user can be modifying the file system, but multiple can be reading. And I'm a user, and I don't seem to remember, guys, over the last 30 years of being a computer user, of my computer ever saying, oh, wait, you can't save your file right now because launch D is running in the background and modifying some data.
Well, let me qualify then. When we talk about a user, like multi-user read, multi-user write, or single user write, in that particular case, we're talking about an individual machine. So you're talking about a direct attached storage, which is like, your USB drive or your things like that.
Okay,
where
so
you're not-
one machine can have multiple users writing to
Right.
the media, but some of those users might be humans, some of them might be pieces of software, and some of them might be these invisible pieces, or to most of our users, invisible pieces of software that they don't even realize are running moment to moment.
So those are all operating, but what I was sort of trying to maybe poorly get to was that, the file system, you can have it be reading constantly back. It understands that. Where it all falls apart is when you have multi-machines trying to write to the same file system. Is that each of them might get the file system itself is stupid. So the machine is going to ask, hey, I want to write this file. Where can I write it to? It's all happening way down deep, deep below the surface. And what's going to happen is it's going to say, okay, you can write into these blocks. Well, the problem is that because another machine is going to make the same request, it will probably overlap and say, well, you can write to these blocks too, because the file system isn't going to be able to know that there's a difference.
So
whereas the blocks, when the blocks are already written, when the machine asks, I want to read from this file, those blocks never change. They're always going to be the same. That file is going to always have been written in the same place.
So let me ask you a question then. So let's take this into a real world example. We sell people sometimes our own file servers. We'll use this as one quicker example of a file system that we use in the real world. We sell people a server. It's going to just be a file server. They're going to hit it over a file sharing protocol on an IP, a TCP/IP network, Ethernet network. This might be one of our boxes that runs sort of the OpenE operating system. It might be one that runs sort of our Chesapeake Linux variant that we kind of use for our own dark purposes, CS Linux. Not an official Linux distro, by the way.
Nefariously backing up your data so it doesn't get lost.
Yeah. So we
So why does it work? Why can you have multiple people write over a file share?
So, okay. We sell someone a file server.
Mm-hmm.
That file server is running the operating system that's running that server, usually a Linux variant, not always, but sometimes, usually. And then that Linux, okay, we put a whole bunch of drives in that server, and it has a RAID controller card, and we set it up to be a file system. And last time I remember, we have multiple users hitting those file servers, both reading and writing to that file system at the same time. Everything you're telling me, does that mean that the file system that we use for those NAS, those network attached storage devices, those file servers that we sell on those TCP/IP networks, are those multi-user file systems? Because those are multiple machines writing to them at once.
It does not. So what in that particular scenario, that's what's happening is whenever you write through an AFP, NFS, or CIFS or Samba share, that's what I would refer to as an application level write. So those file systems are file systems in the loosest sense, because they're really more VFS or virtualized file systems.
Those file sharing protocols,
right?
Virtual file system.
Right. You would never, if you had a block level device and you put it into your machine and it said, I don't know what this is, please initialize it. You would never see an option to format that as SMB, CIFS, or NFS.
Those are sharing protocols.
Those are
That's
sharing
different.
protocols that basically what it is they read from the block level device. They abstract. So they basically they're looking at the file system and then they're reordering it and presenting it as another file system.
But it's not really.
It's not
really.
a block level file system.
It's kind of lying.
It's a virtual
right?
file
It's
system.
sort of lying
virtual
to you.
file
It's an application, right?
So just because I'm in Finder on a Mac or Windows Explorer on Windows and I connected to a file share, and it has a little hard drive icon, much like my local drive. Maybe it has a couple of guys holding hands if I'm on the Mac.
Sure.
And I open it, Finder opens it, I navigate through it just like it's any other drive, any other directory, my startup drive. But it's not the same, even though the behavior and the experience of interacting with it is the same.
Right. What is happening is the reason why that all works with multiple users reading and writing is that at the end of the day, it's all going through a single machine that is writing to its local storage.
What
File
machine is
server.
that?
It's the file server.
So that's your file server, NAS head.
So the server that is the file server that has its own onboard storage, it has the one machine reading, both reading and writing.
It's the one that's committing the data.
Is the file server itself.
Yeah, you're writing through that machine to the disk.
You're basically, as
So
the
does that-
user,
block
telling the server, you can write this, please write this file, and the server is saying, okay, can I write this file? Yes,
So
I
what
can.
file system is it actually running? In the case of those little OpenE file servers.
99% of the time we use XFS.
So what's XFS?
So XFS was actually, I think it was developed by SGI originally. Actually, it might even been. You know what? I might be wrong. I think XFS actually might have come out of the. Remember the Real Media Player people? Mm-hmm. I think they might have.
Interesting.
That sounds vaguely familiar.
I can't remember if I might be remembering that wrong. But basically, it's a low latency file system that has the ability to store, hundreds of thousands of files. So basically, the reason why we choose that file system 9% of the time is that if you look at traditional Linux file systems like ext3 or ext4, if you ever wanted to see it break real quick, just do 4i in, curly bracket 1 ... 75,000.
He's
right,
talking
curly
demon talk.
bracket, colon, do, and then do touch, and then $I, semicolon, done, right? So you write that once it's a for loop that's iterating through 1 through 75.
That's a terminal command you just gave
Yeah.
us. Okay.
And what that's going to do is if you are on an ext4 file system, or if you're on an ext3 file system, ext3 at around 32,768 files written, it's going to choke. It's going to say, I can't write anymore.
Just to be, vague about that number.
Right. It might be, sometimes it's a little bit higher, right? I don't remember the exact, but then you do the same thing with the ext4, and then that's going to choke it at about.
When you say choke, you're saying because
it's going to not be able to write any more data.
Because the feature of the file system only has
it can only support
a certain bit depth value for number of files.
It can support more than those files if those files live in directories, but a single directory can only support that many files. Roughly, it's 32. Roughly, what you would call 32,000 files on ext3 and 64,000 files.
So that's an issue when you're talking about like an entire movie and a DNG or
Sure,
frame
right.
sequences.
Frame sequence. So XFS does not have that limitation. I have tested it up to 100,000 files, and I know that we've done more than that. So it's been a really good file system which is why we typically use it. It's also, like I said, it's low latency. It has, I can't speak highly enough about it. However, the downside to XFS is that if, depending on the individual size of the volume, we kind of have to limit the overall capacity to about 240 terabytes. Previous earlier versions, we would say, well, let's not exceed 100 terabytes on a single file system, because in the event that you ever had to run a file system check because of a improperly shut down machine, it could require up to like 2 terabytes of RAM to complete that file system check if you grew it exponentially.
So this is an interesting issue that you're talking about, which is that we still find ourselves, this has come up now several times, and we'll move on in a moment, but I want to make this point. It's like, and tell me if I'm right or wrong here, guys, it's like we're kind of using file systems that were designed years ago, despite the fact that we're in the tech industry that has tech that changes like every 2 minutes, that just in the last, 3-4 years, we've gone from like 2 terabyte hard drives up to 10 terabyte hard drives. So you're saying that file systems have these functionalities, many of them, but some of them include how many files can be in a directory or on the entirety of the file system or whatever. And yet we have this hardware that keeps going bananas as far as its growth and how much denser it is, how much space you get out of a hard drive or an SSD. And so it's almost as if the hardware is often outpacing the development of these software and data layers that manage the data storage hardware.
Absolutely.
So we're constantly having, and I know this to be the fact, right? We're constantly looking at what's around the corner and how can we extend into new or different types of file systems or technologies that relate to file systems that essentially allow us to even just take advantage of the hardware that's now on the market, right?
What we definitely are looking at is we're trying to make sure that, depending on the use case, that we're matching the right file system with what the client is trying to accomplish.
So I think we will have to revisit some of the more nuanced details of kind of our file system futures in a future episode. And I'm happy that we get together and do a part 2 sometime in the not too distant future, because I want to get more into what our R&D work is around these new file systems. But I kind of think that with time limitations, we should probably save it for the next episode. So with that said, let's talk about another file system that we have a ton of experience with, that from everything that's been described so far works differently, which is StoreNext.
By the way, just to tie it up, XFS is actually SGI. It was actually originally developed by SGI.
Look at that.
Yeah.
So
Thanks, Wikipedia.
StoreNext, speaking of commercial file systems.
The real media was Isilon, then, I bet. That's probably where I got confused.
Anyway, so and some file systems are open source and some are proprietary, right?
Right. So speaking of XFS, so just to also bring things around, so XFS by inherently is a single user. When I say user in this case, I mean machine
Client system.
It's a single machine read write. Okay, although I guess you could probably have it read. If you set up FS tab on sister servers to read that, it could probably read the system back. But for all intents and purposes, it's not. So they then there's a version. So that's available on just about any Linux distro. I think it's standard now on all the Enterprise Linux 7 derivatives. So RHEL 7, CentOS 7, Scientific Linux, Oracle. It's the default now for the operating system, and for the boot drive. However, one of the things that they had done is they had realized the need to basically be able to cluster it together. So there is a variant of that's not available open source that you have to pay for play, which is called CXFS, which is a cluster file system, and its main competitor is actually in the market space is actually StoreNext, which was originally Centrovision's. That's if anybody's ever curious why it's called CVAdmin or CVFS. Centrovision file system.
Okay, but now it's StoreNext.
So now it's StoreNext.
So very briefly, we don't have time to get super deep.
It's a cluster
diving.
file system which allows.
So what's that?
So what that is you have a set of metadata nodes, and those metadata nodes are not responsible for writing the
nodes
data.
are servers, right?
Yeah.
Metadata servers.
Metadata servers, nodes.
These are the Excelis servers in an Excelis, or if you have
workflow directors.
You have an M441 or an
Metadata controllers,
M661.
whatever
File system managers, they're sometimes referred to as. Yeah.
Right. So what they are responsible for is for not writing in a NAS environment, the server itself is responsible for virtualizing the block level file system and resharing it to clients. And then it's also responsible for reading and writing the data back as quickly as possible.
Because it's having to do it for all connected users.
Yeah. It sounds like an awful lot of overhead.
Right. So
StoreNext is different.
So
how?
StoreNext is different in that you have a set of metadata controllers that are not responsible for writing the actual blocks of data. They are responsible for writing basically where that data is being stored and where you're allowed to, the individual machines are. But what's actually writing the data to the disks are multiple machines.
So that's a SAN, right?
That's a SAN.
StoreNext is a true SAN.
StoreNext is a true SAN, true cluster file system.
Storage area network.
Okay, so let me just reiterate here. That means StoreNext has a few unique functions. Number one, because there are these servers acting as metadata controllers, and one thing we didn't mention, but I will for the sake of completeness, they actually communicate on a network that is an Ethernet network, an IP network, that isn't your general house network, and it's not the fiber channel network that the data actually gets sent over. It's a quote-unquote file system metadata only IP network.
There's that word again.
That those metadata controllers use to tell all of the various clients moment to moment, you, editor A, you're ingesting video, so you can write to these sections of this clustered file system, and I'm going to pre-allocate them for you, and no one else can write over them.
It's like it gets write tokens.
So it's basically acting as a traffic cop.
Absolutely, that's the number one thing that people
that's
describe
what makes
so
because StoreNext has features that are both features of the software, but then get baked in via the metadata controller servers that are on that specific IP network that also all the SAN clients are connected to, that passes all of these tokens and data about who can write where at what moment, but they are actually writing to the underlying storage individually. That's features of the StoreNext file system that not every file system has. And what an interesting thing that we've all known for many years, and I think is why we've done a lot of StoreNext business, although we've done certainly a lot of NAS business as well, file servers, is that, in these file server scenarios, for many years, I think we were, Brian, you and I, going back as many years as we have now at Chesapeake, at first we were very reticent at looking at NASs and file servers and TCP IP networks as real-time post-production edit and graphics storage environments. It took gigabit and 10 gig and now 40 and 100 gig Ethernet, better Ethernet switches, better servers that just had more power, the right selection of file systems to allow us to sort of, cajole them into being sometimes perfectly acceptable real-time post-production storage systems. But because that's a little more recent, we had for many years focused on XSAN, which really is StoreNext under the hood, and then a much more direct relationship via Quantum and StoreNext, because it was really written to do these things as a very baked-in first principle of it as an operating system, as a file system, I should say.
And that's really the big difference, is that StoreNext is a file system. These file servers are not. They're virtualizing a file system.
Now, some of them, well,
let's all right. So here's a lot of people will confuse NAS for SAN and SAN for NAS.
Right. Good point.
And it tweaks me to no end. Besides the very different, the major founding factor is that if you don't know if you're on a SAN or if you're on a NAS, it's who's actually writing the data to the disk. So if you are writing through AFP, NFS, SMB, it is the server that is directly attached to those disks that is writing the data to the disk.
It's almost like your client is performing a high-speed transfer that's so fast, but then it's transferring it to the server and it's writing the data to the underlying file system. It's almost more like a transfer that's just happening quickly and tricking you into thinking you're working off of the storage.
Exactly.
But it's really only the file server.
Obfuscated from the user.
Right. So and there's benefits to that solution. But if you want to know if you're on a SAN, now here's where it gets tricky is sometimes there are these hybrid things called IP SANs, and that has nothing to do with iSCSI, just to put that out there. A lot of people think, I connect to my storage or I'm running a StoreNext SAN, but instead of using Fiber Channel, I'm using iSCSI. Still not the same kind of thing. There are things called IP SANs, one of which, is the most interesting to me lately, which would be like Gluster FS, which ditches the whole metadata controller notion. Instead, it has these storage nodes. Now, if you have an all Linux environment, you can have Gluster servers and you can have Gluster clients. And the interesting is you have these storage nodes, and when you're not writing through an abstraction layer, you're writing through the file system itself. So if you have one part of a file that's been distributed across two storage nodes, even though the information is traveling back and forth through TCP/IP, not through block level, you are actually on an IP SAN, okay?
Right.
Because you are talking to the storage node who's then delivering you the file, not a single, abstraction that's talking to a direct.
Okay.
But that being said,
that's really the difference. I mean,
So yes, there are
back
things.
to what is a SAN, what is a NAS?
And there's
the difference.
Panasys, which is also, again, here's a great thing. If anybody's familiar with Panasys for years, or Luster, if you have a Luster, or a Panasys, storage system, and you are connecting through, if you mount it as NFS, your Panasys is functioning as a NAS. However, with the most recent version of their DirectFlow client for Mac, if you start mounting it as PanFS DirectFlow, that same system, you now are on an IP SAN.
So sometimes they can double duty, and it's because the underlying file system is capable of serving both types of clientele.
Correct. Just like you can actually put a NAS head in front of a StoreNext file system.
So got it. So, okay, let's save some of our explorations and deep dives of what next generation file systems that we've begun to explore and what makes them unique and how they take us the next 10 years down the road. Let's save that for File Systems Part 2. I want to take just the last couple minutes we have now.
Well, I want to say one thing just to get...
Please, say it.
So the one thing I want, because I have a feeling, given the state of this particular show, that somebody's going to eventually say, well, why are you using X? Because you can look up XFS. It's not a new file system. Why would you use that? Why aren't you using something more modern like ZFS? And the big thing to keep in mind is that it takes about 10 years for a file system to mature. And the reason why it takes that long is because of adoption. right? You can't figure out what's wrong with something if very few people are using it. And so the problem is you have to sometimes go with the lesser of two evils. So yes, is XFS perfect? Is HFS perfect? Is NTFS? No, none of these file systems are they modern? Not really.
And sometimes there's licensing issues, there's cost issues,
absolutely.
or they could even be murky licensing issues where they're sort of open sourcey, but the way that the licenses are written is that
Sounds like you're talking about FFmpeg.
The companies that own them could decide to change their policies.
It's okay. It's okay for you to install it, but we as the reseller can't.
And because we're making decisions, as hopefully listeners to this episode, all 5 of them will be able to tell us afterwards when quizzed.
Right.
They'll understand that there's a lot of nuanced factors that Chesapeake is looking at when we say this is the one we have chosen. It's proven, it's been out there for a while. It has a certain feature set that's compatible with the use case. We aren't afraid of any weird licensing issues emerging. And the reason, and I'm kind of going into my sales guy mode here, but it's something we're all obviously really passionate about. We are literally making decisions as to how your most essential data as a customer of ours is stored on the physical pieces of IT equipment that we are potentially selling you. And like all other aspects of quote unquote workflow, we take those decisions really seriously. And it's not just technical factors, and it's not just pricing factors, and it's not just licensing and intellectual property factors, and probably 4 or 5 others I could think of off the top of my head. We do, guys, please assure me. We look at these things, right? I mean, we're thinking about these things. And Brian,
right, Mr. Solutions Architect.
Well, I mean, I look at things in a very.
Ben's like, oh yeah, I look at it all right.
I just asked Brian, and Brian says yes or no.
Well, this is the thing, and this is why we say Brian is sort of like the man behind the curtain, because the reality is we have Brian here working on this type of R&D, this research, developing, playing with things, experimenting with file systems, understanding what the world at large and the community of people who both build these file systems and have to support them as admins. I mean, we have Brian kind of in the background doing this as a major part of his job that then kind of spreads out across our organization. Seriously, I mean, the amount of man hours in any given year we have Brian kind of hacking around with file systems, I dare say, is probably more than most other systems integrators, and probably only rivaled by very large IT firms that are doing this with massive, massive enterprise deployments, and of course, so they have to be. And the storage manufacturers themselves, who are often writing or at least using these things.
And I guess the big thing is, I think the thing that I want most people to know is that, we think about these things because we have seen both sides of the coin, so to speak, in that we went with what everybody else went with because we thought it was safe, and then we hit these limitations, or we went with what the manufacturer had recommended, and it turned out that the only reason the manufacturer made that recommendation is because they had done it was the default. Like we've had a lot of recommendations on file systems that quite honestly, it actually made some products, because of the file system they chose to use, it did not scale.
So you're saying that?
I guess the whole thing is like there's an active thought process.
So I think it's really safe to say that this is literally the thing that keeps us up at night.
Ugh, tell me.
I don't know about you. Yeah. It keeps me up.
Oh, yeah, I have insomnia.
Because the data's exponentially grown so much. Just when I first started, we had 14 drive Xserve RAIDs with 180 terabyte drives.
Yep.
Padded drives. Parallel ATA for those who recall. 133. Right? State of the art. Thank you, Alex Grossman.
Back when I was in my 20s.
Right? So then when they bumped that up to like 250s and then eventually 500s, it seemed like wow, like who could ever use this much data? But we were also living in a standard definition world. And
now we're in a 4K.
now we're in
and
a 4K
360 video,
yeah.
360-degree video.
It's growing so much. So I've been with the company now well over a decade. We'll just say that. I know it's probably verging on 13 or 14 years.
I think it is 14 or 15 actually.
So in
Brian.
that time, so just just put it this way, in the time that my daughter has been alive, which is about, in March will be 9 years, we have gone from where like the largest
physical drive
was a terabyte to now like
an order of magnitude larger.
Literally,
we're at 10 terabytes. We've gone 10
terabyte drives.
10 terabyte drives. And at this point in time, it's a whole other discussion to even say has rate.
You just set me up for the best possible segue. So I'm gonna just write it out here, and we got like 5 minutes to chat about this. But you just set up the best segue.
Is RAID enough?
So okay, we like to think of ourselves as a forward-looking, progressive, tech-savvy, kind of org. And I just said we're always trying to keep on top of these factors that are changing in the tech industry and making sure that our own skill set is staying kind of in tandem with these changes. You just mentioned a big one. Hard drives are getting really big. So we don't have enough time to delve into the RAID side of things. We'll do a whole episode on just this subject, I promise.
Let's not.
You don't have to be on it. It's fine.
Let's just walk away with this and say this.
We're good.
This Aspergery guy, Brian, he made it very clear that RAID is not backup, and that if anybody uses RAID in the same sentence as backup, they are
wrong.
It is true that would
just say wrong.
Woefully wrong. RAID is to minimize your downtime.
Do we want to say it actually makes you bad?
No,
okay. We don't want to. We don't want to.
No,
say that.
I just, it's just one of those things. Like it's. I've been an end user. I thought RAID was this great thing that would keep all my
data safe forever.
And then the first time your file system becomes unwrapped, a partition, your RAID's fine, but your file system label became undone, and then you're like full on like, all right, well, how do I get this back? And then you buy like data rescue software for like way too much money, and then you restore all your data and you find out that none of your data has names anymore. They're all just they restored your data as what the inode numbers were. So you don't know what was a JPEG and what was an MOV, and so you have to sit there and just like
open everything
methodically, because all your resource forks are gone.
Can you imagine that in a file that has hundreds, if not thousands, if not tens of thousands of elements?
I experienced it with a 500 gigabyte, 10 years ago, and
and now we've got 10 terabytes.
Yeah, I couldn't imagine. I remember painstaking. I gave up.
Okay,
I gave
so
up.
let me make this final point that we will only spend a few minutes on. We're calling this episode, and again, we'll continue with a part 2 and get more into this, but file systems and beyond. We've talked about how for disks, like hard drives and flash memory, we're not counting things like tape drives here because the way that they record data onto a tape is so different. But we're talking about these random access physical data storage mediums like hard drives and flash memory.
Yes, SSDs fall into this category.
So when looking at those types of storage technologies, we at Chesapeake are saying, oh my God, I've been with Chesapeake for 12 and a half years. Brian's been here for roughly 14. Ben's been here for 8 or something. Jason, you've been at least
2.5.
Yeah, but you've been on the buddies list for a lot longer than that. That's for darn sure. I mean,
on the private guest list.
Jason Whetstone, by the way, was the very first person, or at least the organization he was with, was the very first outfit we sold Final Cut Server into, and that was a while ago. Yeah. So we've known you for a while, and we, reading our tea leaves, knowing that we have 10 terabyte hard drives now, we had 1 terabyte hard drives 10 years ago, or even like 8 years ago.
Western Digital is threatening 20 terabyte drives by...
So this is what I keep hearing. I keep hearing that 20s, 30s, 40s, 50s, like we'll see those easily in the next 5 to 10 years. Like there is a good chance, not a perfect chance, but that same order of magnitude we did in the last decade, there's a chance it'll be roughly another order of magnitude in the next decade. And then you're talking about a single hard drive that could be, I mean, think about it, 100 terabytes on a drive. So let's pretend for a moment, as we often do, that might be the type of reality we're dealing with, or even a 40 terabyte hard drive 5 years from now. Some of that...
Yeah, what's the data transfer rate going to look
so
like at
here's
that
the
point?
thing, right? And we'll only touch on it now. But some of those storage systems, the physical developments that are happening with hard drives, because all of those same density improvements are happening with flash memory too. So even if you talk SSDs, from what I've noticed as of late, the density of SSDs is actually growing much more quickly than hard drives right now. So are these file systems the right way from that software and data layer perspective for us to imagine we will likely be storing data on either these same file systems or even, dare I say, file systems at all in a few more years, in 5 years, maybe even now? And so, of course, the elephant in the room that I'm implying here is this whole other methodology of storing data on hard drives and SSDs or flash memory that isn't file system technology. It's this other thing called object storage.
Object storage.
So, Brian, you're the guru. You tell me, and you already did years ago, so tell me again, and our listeners. What is this object storage thing that everyone's bandying about and saying that this is the future of our storage industry and this is how you will be writing data to large collections of that could be petabytes in size, that could be spread over multiple locations, that maybe are not as susceptible as RAID to the types of data loss scenarios that you were suggesting earlier, that are even technically compatible with a 40 terabyte hard drive theoretically several years from now. What are these object system things? And just in a nutshell, what differentiates them from file systems?
This is the cliffhanger for episode 2.
Oh,
Just
yeah.
keep that on the top of your head.
All right. So I mean, so basically, object storage, it's less concerned about the blocks and it's more concerned about what the actual data is. So when you talk about like parity, you're really, what you're concerned with is like how many times this file repeats across multiple nodes, and a node not being a disk per se, but a whole separate server. So it's complicated because in truth, and part of the reason why I'm hedging this a little bit is simply because there are some object-based storage companies out there who are not really object-based, but they're
maybe kind of in between a file system and an object store.
Right. It's one of those things. So it's and then there's some people who they claim to be object-based RAID, which is not quite the same as object-based storage. So it's really kind of hard to nail down in 30 seconds or less what object-based storage is, because you kind of have to weed through
maybe we can
what we're talking about versus what marketing of other companies are
let me
talking
put
about.
it at you from this perspective then.
But it's about the integrity of the individual file. So the file itself is basically your folder trees, your folder structures. They do not exist in terms of directory
There isn't
entries
the root,
and
and
inodes.
there's no folders
They
you
are
create.
no folders are virtual in the sense that, like, if you go to Amazon, S3 storage, when you are uploading a file, you are uploading this object. And the big thing with object-based storage is that true object-based storage is limited to I believe 3 commands, which is like put, get, and delete. So when you want to rename something, what you're actually doing is you're putting a new copy someplace and then deleting the old one.
Sometimes there's posting involved.
The put and post are kind of
Yes, put and post can be used interchangeably.
interchangeably.
So okay, okay, remember, just trying to get some big picture
Sure.
ideas out there. So another thing I've noticed is, there's no way around using this word in this context. So one thing we do with file systems is we like to mount them, right?
Right.
So I know I like mounting my file systems. I mount
What
them
does that
good.
mean?
So what does it mean to mount? So when all of these file systems we've been talking about, when you as a user who has on whatever your client system is, that Mac system or whether it's a server doing something, we've talked about how you sort of have to have a driver to the file system to make sense of it, right? To read the data, write to the data.
File system client.
You have a file system client, and when you connect to, which is really just another way of using the term mount, but we do use the term mount when talking about mounting a drive. When I plug that external USB drive in and it pops up on the desktop and I get the cute little hard drive icon, or if I were to look at it in terminal, something with that drive name now exists at /volumes/, or in Windows, it's mounts and it has a drive name, but it's at C:, or D:, or E:. Those things, like, okay, I've connected to it. There is a hierarchy of folders. They're named certain things. There's the root or kind of original
You can
layer.
walk the file
You
system.
can walk through them and navigate them. I can organize them with subdirectories and sub-subdirectories and sub-subdirectories. And
Object-based storage.
you don't do any of that. Usually.
Well, so
Directly.
again, it's one of those things. It depends on. There's a number of people who one of the truest object-based storage out there, I believe, is the Amazon S3 that most people would be familiar with. There are a couple of very pioneering Fuse projects, which is a whole other topic, file system and user space, that actually can virtualize
An object store.
an object store like S3 and make it appear as like a network share.
But it's
mounted on
kind
there.
of like
What
the
it's-
same lie that a file server is telling you.
Yeah, it's so. But I guess the biggest thing is that if you've never experienced object-based storage, if you've ever used like FTP, and again, I know it gets a little shady because there are some virtual FTP clients for the Mac and Windows. But if you've ever used a thing like CyberDuck, which is a really popular freeware on the Mac, you can kind of get the idea of what object-based storage is like. It's a bunch of files that are, not
Somewhere.
they're just all at the top level. There's no directory entries. There are virtual directories in the sense that you can tag it with metadata that says that yes, this file's name is technically /x/y/z, and the file's name is foo, and then it can present a directory tree to you. But if you were to look at the abstract file system itself, there's no directories. It just happens to be that something is saying every time you see a / in a file name, interpret that as a virtual folder. So it's basically just a bunch of data that is replicated across many nodes being servers with their own storage, and your redundancy or your protection is that you have more than one copy, so that if you get something like a bit flipped or bit rot, it can read from the alternate copy or copies, and it can then repair that so that at all time, and really with the power of object-based storage is, unlike RAID, is that when you are rebuilding a RAID, if you have 10 terabyte drives, you have to rebuild 10 terabytes worth of parity.
But here's the thing. Okay, without getting into the data protection side of it too much.
Sure.
The other thing about an object store that is forcing a change on people, and again, we'll save this for the real deep dive object store episode that Brian Suma may or may not be featured on.
I guess I didn't make the cut.
Well, no, what we'll do, we'll just use that new feature in Premiere that lets us be able to say anything in your voice. And we'll just basically, say what we think you would have said. And I swear we won't say anything that you wouldn't say.
All right.
Oh,
I swear.
I don't know, Nick.
I swear. I swear. And as our listeners can tell, there isn't a whole lot that's probably like not in the territory of what Brian might say at a given moment. So it's really anyone's guess. But anyway, software as in the applications we use, including our operating systems and including sort of the apps that we use, Premiere, CatDV, Reach Engine, our web browser, CyberDuck you just mentioned. In order to use them with object storage, the apps that we use have to be written usually to even work with object storage, right? Like
Right, so
an app like Premiere, you can't just ingest files typically. Again,
Right.
some object stores have features on top of them, but forget that for a moment.
Right. So Premiere, in order for something like Premiere or CatDV or whatever, what it has to become aware of is right now, it basically has to become aware of URLs. Okay. So you might think, all right, well, most things are aware of URLs because anybody who's ever done a deep dive into like XML of Final Cut 7, which is actually what Premiere's XML is based off of.
They were using URIs.
They're URI, but they're all local.
Yeah.
Yep. It's
Right?
file://
Yeah, it's like localhost, point, whatever.
Yeah.
But what needs to happen is that they need to basically be able to, and this is like the weirdest, this is going to be the weirdest thing. So something like Premiere, in order for it to work with an object store, it's going to have to do two things. One, it's going to have to understand what that URL is pointing to. And it's also going to have to kind of understand that it's going to have to like fetch it and cache it somewhere locally. And that because for the time being, I think it's going to happen, but object store is not particularly fast.
It's not production storage.
We talk about the features of these things and we talk about the features that are in file systems. Well, the modern file systems that we use and we put on either your local storage or your shared storage, they have features that make them conducive to an application like a nonlinear editor or like a graphics application to be able to shuffle data in and out of them very quickly in a way that is very specifically engineered for an app like that, which is doing all sorts of crazy data caching operations in the background and that even you as a user are not typically aware of. Those file systems have features that make them very good for pieces of software that need to do all that kind of stuff on a moment-to-moment basis to use them effectively, whereas some of these, especially the more raw object storage platforms that are out there, which I'll mention, you need to put data into, as Brian said, with a put command. Well, that's an API call. So you need software that talks in the compatible set of APIs to even put a file in it, get a file out of it, delete a file that's already in it, post and maybe get some information about it or something. Whatever that is, the apps need to be written in a way that's even conducive to it. And those object stores themselves, there's a lot of challenges with getting that much data moment to moment with a large number of client systems in and out when you are expecting very real-time performance out of it, like when you hit play on your spacebar.
I have a 250 gig video that I need to play back.
I want to hit spacebar and I expect this video to play. And when reading data off of a file system, Premiere is like A-OK. Doing that out of an object store in the more raw form is going to present a challenge and might not even be a necessarily appropriate utilization of object store technology. So I guess the main point...
It's kind of if anyone's ever gone into, Brian mentioned CyberDuck earlier. If you've gone into CyberDuck and you've said, oh, here's this PDF or this text file on this FTP server that I want to look at, you can spacebar that file just like you can in the Finder and preview it. But what's happening in the background is that's actually being downloaded. And it's a very small text file or PDF. It's being downloaded and put into your cache folder, and that's where you're actually looking at the file.
And so we would need to rewrite all of these apps from top to bottom, or at least their data handling capabilities, which probably no one is in the middle of doing right now. So I guess the point I'm making, and Brian, you're the guru, you tell me. I think that probably if we were to have this chat 5 years from now, which likely we will, at least at the rate we're going. If we're talking about this 5 years from now, I would wager that out of all of the disk-based storage platforms we're selling people, we will continue to be selling systems that have file systems, including potentially file systems that either are some of the ones we're selling today, like StoreNext, or maybe derived from, or maybe you could say next generation versions of ones that we're using today. similar in maybe top level principle, but okay, now we get a chance to rewrite it 30 years later. What would we do differently? So I have a feeling we'll still be using some familiar to us today, some that we can talk about in a deeper dive to our kind of next generation file system workflow show episode in maybe a few more months. But I also think we'll probably be selling more disk-based storage that people are using as object stores, but that neither one of those two technologies is anytime soon going to completely put the other away. If anything, I would imagine that 5 years from now, our clients have much more heterogeneous environments where for some disk-based data storage applications, they are using object storage. That's typically going to be mediated by certain software layers in between. And others will, the very same department might continue to use a file system-based shared storage system as like their production SAN.
Right.
But nearline becomes an object store that you get to through your MAM and not just another drive that you mount as a file share.
Or maybe if it's managed automatically somehow, and that, this is a project that I'm currently working on now. This is all going to be pulled out of the object storage onto my production storage where I will edit from. And it could be managed by time as far as like how often do I open this project, how.
And the little secret is that we could kind of do this today
well,
using something like a workflow and the Reach Engine platform that we work with.
It could be done
In
like
fact,
that today.
Many people are
But
today
if we're
starting
talking
to do
about
that.
Premiere, not necessarily a MAM, we're talking about Premiere.
Sure.
I would see, maybe in the next 5 years, the capability being that we actually still work off of some sort of a local file system, whether it be a local driver or SAN, but maybe Premiere sort of intelligently manages this shuffling of data from the object storage to the production storage based on some criteria. How often you open that project, when was the last time you opened it, something like that. So
almost like
I would argue it would be.
Okay, you tell us.
There'd be So my argument would be, I don't think, and I could be wrong, but I don't think Adobe. I don't think the Adobes, the Apples,
Avid.
the Avids are going to integrate directly with object-based storage.
I agree with you there. I'm just
not
saying,
anytime
I totally
soon.
agree with you.
Not the 5-year roadmap.
I think more realistically, what will happen is a file system, possibly StoreNext, which I know that's already kind of on the roadmap. But what they'll do is they'll act as a traditional front end to an object-based storage, which I know is exactly what StoreNext claims
that's sort
to
of what
do.
StoreNext with Storage Manager in mediating the flow of data between it and a Lattice object store.
Yeah, and so I think what will happen
Cloud.
is you will have basically a file system that is maybe made up of smaller SSDs, smaller, faster SSDs, so maybe like 1 or 2 terabyte SSDs. That's basically acting as a disk cache for your object store.
Do you think that will be a new or a modified file system that hits the market, say, or becomes a new community project if it starts as an open source thing? And so what you're saying is the file system layer will start to emerge as something we all kind of inherently see as a caching tier, because we all start more and more to take for granted that our bigger data sets, the big data, is probably primarily living in an object storage world,
Right.
but that for almost any industry, the need that will then start to occur is that local file systems are really just the thing you need to host those files for certain types of applications to work with them on a moment-by-moment basis. But it's almost like a file system might be mediating what's coming in and out of the object store moment to moment, just as a basic feature. And that, that's almost starts to become what the core job of a file system is acting as a more nuanced cache tier.
Yeah.
And, by the way, I think you're kind of right. I'm just going to throw that out there.
Yeah, I mean that's what I think is. I think that because if you've ever met or worked with any developers, they very clearly they're often very quick to be like, that's an application issue or that's a file system issue, and it's like that's not our problem to resolve. And so I think that when Adobe is going to do what they're going to do, Avid's going to do what they're going to do, Apple's going to do what they're going to do, and more likely than not is that there's this thing that's worked out very well, which is interacting directly with a file system traditionally, and maybe in 20 years they'll working off of object stores. But I have a feeling what will happen is that somebody's going to come along and they're going to say, okay, it's the job of the file system, not the application, to work with the object store. And so there's going to be, like I said, this disk caching layer in front of it that, like I said, will essentially be basically, whatever criteria it uses, but it'll basically, everything will live in object store. So as you start to ingest to your disk cache, those writes are going to start getting dumped right into the object store. And then I think as you start to request those, it'll recall those, and then gradually they'll expire.
And basically, I will say, and this will be the maybe final thought before we say our thanks and goodbyes, but that is, I think, the vision of what Quantum Store Next really offers. The problem is that Apple has an issue in Finder and Terminal, I believe, that prevents us from fully taking advantage of it. However, if you had a non-Mac environment, that's a big part of what the whole Store Next Storage Manager package is once you start using the actual policy-driven systems for data flow between the file system layer and the object store layer. If you're using something like Quantum's Lattice object store system, or you're using Amazon Web Services as your object store, or public cloud, which is all object store. So listen, clearly we have some follow-up episodes to do. This has been great. It's always a pleasure to pick all of your guys' brains, all three of you, including Ben here, of course, and Jason Whetstone, regular co-host, as well as the esteemed, the man behind the curtain, the
great and powerful Oz,
Brian Suma. Holy cow, man. Woo. It's just, we get blown away by the level of knowledge in the man.
That's right.
Which is why we're cloning him into an army that will take over the world.
It makes me sad that you guys are so easily impressed.
We have miserable lives. We have horrible, miserable lives.
Well, my life isn't real miserable.
But the truth is,
I'm pretty happy.
We're not easily impressed.
No, Brian is just one of the more modest people you'll tend to meet, which is part of why we love him. All right, Brian, thank you so much. Thank you, gentlemen.
Thank you, sir.
And we totally blew through the hour, and so be it, man. Right. I guess this is just how long it takes us to do workflow shows. And if you've been with us this long, thank you. And stay tuned for the next ones. Take care. Bye-bye.
Bye.